My name is Michał Posłuszny, and this presentation is about SQL, about integrating Go with SQL and user experience that comes with it. So I am a software engineer at Splunk SOR, and during my professional time, I mostly write in Python and C++. So you may wonder, why am I talking about Go, about integrating SQL with Go? So the reason is that I love to write using Go in my personal time for my pet projects, which I rarely finish. But let's say I want to have something from those projects other than just unfinished piece of code. So I come up with an idea so that I will turn up one of my research for creating an budgeting app in Go. So I was creating that app, and during that I couldn't just find the right piece of tool to write my SQL code, and because of my perfectionism, I was just going deep into rabbit hole of every possible tool there is here. So I was basically looking like that when I was in that state. But from that came up this presentation that covers a few things. So we'll talk about low-level approach, so libs that let's say lets us write SQL kind of raw. Then we'll move to ORMs, so libraries that are more abstract. After that, we'll talk about some alternative approaches, which are, I would say, specific for Go. After that, we'll compare them with some benchmarks that I found out. And after that, we'll sum all of these things up. I'll tell my subjective, let's say, opinions about in which case I would use any of those tools. And at the end, there's also a place for tools. By that I mean things that helps us to work with SQL but are not for writing the code. So things like migrations, writing tests, etc. So starting with introduction, now we'll cover what will be covered in this speech. So we will focus on usability. So we will focus on how each of these tools affects our writing codes, our thinking, the mindset that we have during the development. It will be only developer focused, so you should not expect any deep dives into the SQL drivers. We are assuming that the presented libraries are good to go with and let's say the most popular implementations of SQL. Then, as I said before, we'll cover the best use for each tool, so the best situation where you should use it. And we'll also mention the popularity and maintenance of each of those tools. So you'll see which of them are the most reliable and supported. So starting with low-level libs, so those are the ones that will make you click caps lock all the time. So you'll write a lot of raw SQL, and you will have a lot of control over the thing that you write. So we need to start with basics to have a common ground to comparison. So we will start with database SQL. So this is a library that is in a standard lib of Golang, which is great. And not a lot of languages comes with this, let's say, opportunity to have like a common interface for different databases. You need to install the drivers to work with that, but you have the common interface for that. But it is at the same time great as it offers a lot of performance, but as you may see here, there's a lot of boilerplate around the code that we write. There is a thing that is specific for Go, is that we are always getting error returned, so we need to handle it somehow, or don't if we don't want to. And the most important thing is that we need to do row scanning manually. So if you want to translate anything from the return output of the SQL to our structures, we need to do it manually, which might take time, might be tedious, and thing that we can copy paste from one query to another. Another things are transactions, so kind of similar thing. We have everything in separate functions, so really great control. But it can be done, let's say, with better user experience. So that's it. And the same case with errors, we need to handle them. That's it about the basic database SQL. As I said, it's just our standpoint. That's where we are starting with. Now let's talk about how we can enhance it. So here is sqlx, a quite popular library that originated from Rust and was also implemented for Go. What SQL gives us is basically the enhanced experience of database SQL. And that enhancement is mainly mapping structures to our queries. It goes both sides, so we can map query output to our data, as you can see here. So it can be either a single object or the list of objects. So that makes our works way easier. But the second thing is that we can do the same thing from the other side. So we can have named queries in which we can use like those keywords, which can be translated from our structure. So we can like create that map with the right keywords, as you can see here, our names to columns in our database. And after that, we can just easily input our structure here to make it more pleasant to use. Another thing in sqlx is must. So this is a thing that is not like standard for Go. So in this case, we are either doing something or our program is dying. So we need to, those things need to happen. There's no error handling on our side. Either we are doing it or we are breaking let's say the code. So that's it regarding sqlx. So a small enhancement. But we can go further. We can go to ORMs and replace our raw SQL with Query Builder. And with ORMs, we'll introduce some kind of magic. So we will not write raw SQL. We will see some functions like create, update like single column, but we will not know what is happening behind. To do that, we'll need to go to documentations, go to the open source code to optimize and see why our queries are not performant. So we'll start with the most popular one, which is GORM. GORM is also, let's say, the most pleasant ORM in my point of view regarding Go. It is let's say, has a really easy interfaces. It's great for CRUD operations. So that stands for create, replace, update, or delete. So you can see here that all those commands can be done through simple functions by just putting in our model in there. The other interesting thing here that you can see is the auto migrate function. It is interesting because we don't have, let's say, full migration implemented into GORM. So we only have the simple auto migrate that will fit our current database into the schemas that we provided at the beginning of our runtime. So that's not ideal for production use cases where we would like to keep revisions of our ORM, so keep versioning of it as we version our code. So for that, we have a solution that will come later. But moving back to GORM, another important things are transactions. So as you can see here, we have a more pleasant way to write transactions. So we can basically have a function that has a, let's say, anonymous function as an input, which in that just calls anything that we want in case of, let's say, an SQL code. And depending on the return of this function, we'll either break it, we'll roll back our transaction if we return any error, or we'll commit it if we are good, if we are returning nil. And another interesting thing about transactions in Go is that they affect performance. And that is an obvious statement, transactions affect performance. But GORM is specific in this case is that everything is a transaction. So no matter that we are saying we are doing transaction or not, by default, every query that we are doing is inside a transaction that GORM is that GORM prepared. So we can remove that. We can remove that per session or globally, but that might cost us some consistency issues as now, like we are not sure if our ORM is strictly following our SQL state, let's say, because GORM might do some specific things to optimize fetching our models during transactions. Another thing that is specific for Go are code generators. So here we have first library that we see in this presentation that implements that. But GORM gen, so the code generator, was implemented later. So it was not in the root of GORM. It was just an add-on, it's a separate repo. So it was done to make GORM more type safe and more friendly. This is a slogan that they used. So as you can hear, by default, GORM is not a type safe language. And why is that? It is because everything inside GORM is working on interfaces. There are no strict typing, because this is the same problem that we have with sqlx. We need to, let's say, find out at runtime what are we doing with our queries, which affects our memory. So that is another thing about ORMs. They are pleasant to use. But at the same time, they are costly in terms of memory. They cost us more memory and more time to parse our queries. And another interesting comparison in GORM are GORM hooks. So this is the feature that is basically mirrored from standard SQL. In SQL we have something that is called triggers. So triggers are things around our queries. So we can say that after update, before update, we are doing something. And we can do the same thing on the GORM side. So basically we can have the same hooks. The difference is in the consistency of our database. So in the case of SQL handling triggers, we can be certain that SQL engine guarantees that everything will be okay, that this part of query will be done after our insert. But in case of GORM, something might break. We might not be consistent with our SQL. I don't say it might happen often. I just say that we can't be like 100% sure. So, and I see that we lost our pet. That's tragic.
Because of that.
Yeah. But yeah, there's also a way to, let's say, call our Go code with triggers and keeping it safe. But let's say it's a longer talk to have to cover that. So that's it about GORM. And now let's move to AND. AND is another ORM which is more opinionated than GORM. So to start with, AND being opinionated, as you saw on the GORM side, the naming of functions, all the things around that were pretty, let's say, standard. Even they were quite similar to sqlx. They were more abstract, but they were keeping the same, let's say, schema style. But with AND, we are going into completely different direction. You can see here that in definitions of our schemas, which are our tables, we are specifying functions that returns, let's say, fields, indexes, edges, so things that specify our tables. And here you can see also a pretty unique thing that we no longer have rows. We don't have columns and tables and relationships. We have edges, we have fields and entities. So we are like moving our naming from typical SQL database, relational database, to more graph database, which is very specific. But we'll get to that a bit later, because first let's talk more about code generation. So as I mentioned, in GORM, code generation was just an add-on, just a thing that was done like an afterthought. But here it is the core of AND, so we cannot use AND without generating code. So we can see here that we are creating those schemas at the beginning, and after that we need to run go generate to get rest of our code. So it might look weird for someone that doesn't use Go that often, but it has benefits mainly in performance, and in that we have our, let's say, kinda open source code from the package right in our hands, and we can easily see how our queries are generated, what components affects that. So it's quite more easier to read, and at the same time it's more performant, because with code generation we can do strict typing, which we couldn't do in GORM before. So it is also a bit more performant than GORM in this case. So coming back to the topic of graphs, why graphs? Why AND has like a label in their documentation called easily traverse any graph? So it says like I'm gonna using Neo4j and not relational database. So I dig through some forums, some Reddit, some open source, let's say, communities, and the first reason is probably meta open source. And why meta open source? Because they created GraphQL. So with GraphQL, it is not a graph database. That's the first thing. This is a let's say, protocol to communicate next to the REST API, but it's like it gets their nomenclature from graphs, and it's, let's say, a bit graph oriented. And this case of GraphQL being like why it's like that with styling is that, and in their documentation have like a strict points about integrating with GraphQL. So we can see that this influence is quite strong. But I also found a pretty, let's say, not related opinion to GraphQL, which is an opinion from one of the developers from AND, which says that like they did it like that because users like that naming. It was quite intuitive for them. So they said, let's keep it like it. They even like implemented, they are supporting Gremlin, which is the traversal language for graph database. So yeah, and this is really interesting in terms of graphs. It even has like graph-like examples in their documentation. So here's the one. They are basically not only showing how to write like simple SQL queries, they show us like to write graph queries. So here's an example of graph with some owner of pets inside some group. And here's a query for that. For someone that does not work a lot with graphs, it might be a bit specific to read at start. So you can see that we are basically doing query that is dependent on the previous result. So first we are looking for a group, then we are looking for its admin, then for friends of an admin, then pets of friends of admin, and so on and so on. So each result depends on the previous one. So yeah, that's about AND. It's mostly like graph focused. Another thing is this is the first ORM in this presentation that affects our code styling much more than the previous ones, because now we have code generation. Our code base will have some specific structure directed to this, specific to this ORM. And I mentioned before about migrations, so the same here, and does not have any anything related to migration, not even this auto migrate. That is because there is Atlas. It is tool written in Go, and it works not only for Go code, it works for Java, for Python, for ORMs like Django, SQL Alchemy, for things like GORM, and sqlx, which we will be talking soon about. And Atlas is a tool that helps you migrate, helps you migrate databases from one state to another. It also allows you to completely not use any ORM. It allows you to specify your schema in their HCL. So this is a HashiCorp configuration language, as I remember. So this is another way you can like specify your schema and then iterate over it. It also supports revisions through, and to apply any changes to your database, you just need to do the Atlas schema apply command and then point to your database and to your file, and you will see which changes will be added to your database. So I think this is great. I didn't know about this tool before I started this research. Before I was using some tools specific to ORMs in, for example, Python. But another great thing about Atlas is that it provides dashboard. It provides more CI/CD integrations. So it's really, let's say, more full-fledged solution than just adding a migration layer to ORM. So moving down to alternative approaches. So here you will see even more code generation and even more, let's say, things that affect your workflow, your coding. And we'll start with a bit less popular library, that is .sql. So .sql is a library that will allow you to separate your Go code from your SQL code. So you will just need to write like simple comments around your queries, and then you will be able to import this file into your Go runtime and then use these queries. So we can see here example how we can use those queries, and we can do it very similar to database SQL. That is why it is because .sql is based on database SQL. And there's also sqlx, so the version of .sql that is based on sqlx. So we kind of get this structure mapping. You can use any of those and still have this code separation. But we can go even further with code separation with sqlc. So this one, like AND, is fully about code generation. So first, we are starting with 3 files. So sqlc.yaml, queries.sql, and schema.sql. Those namings is up to us, but we can just separate those SQL files into SQL code into different files, and we need to have some kind of YAML configuration. And when we have all those queries, really similar to .sql, we need to name them and say what kind of query is that. If we will return many, one row, or is this exec like command like query. Same with tables, we can create them and we will later get the schema out of it. To do that, we'll also need a configuration file, which you can see here. And this is the one from documentation that you can see here. We can support multiple databases, like having different implementations and different implementations in our code by just adding another type of it. So we need to precise where our files lays and then specify how we want to generate our code. So the package name and the output and also the engine. So we can do it for Postgres, for SQLite, MySQL, and so on. So After that, we are doing go generate, and then we are having our SQL code generated. The difference between that and end is that as I dig deeper into how end generate their code, they are like, you don't have the full database SQL code as you have here. So you can see here that sqlc imports database SQL. This is not the case in end. In end, it's still their own package, and they called it graph query engine or parser or something like that. And that's the thing that creates our queries. So it's still a bit hidden from us. Here we have full transparency in our queries. And here's another example. Here's how queries looks like, generated queries looks like. So what is great here is that the SQL code is separated, the params are separated, and then we have function that uses those params and that query to do our flow. And after we have this, we can just import it. And what's better here than .sql is that in this case, we have full linting support, so we can just input queries, and then it will prompt us whatever query we want to use. In .sql, it is done on runtime, so we need to input like strings to fetch the queries. And another problem with .sql and with that fetching is that we also need to include our SQL code in our binaries. So to do that, we need to use some third-party tools to include them. So that's another a bit, let's say, different thing in Flow that you need to consider. So after generation, we'll have some more files. So we'll have general db.go, models.go, and query.go. So as you saw before, queries where our queries land, models, and db, the whole engine, and the most like common functions that are used throughout, and also the connection and session. Another interesting thing in sqlc that kind of makes it kind of closer to ORMs is embedding. So in case of ORMs, we are not worried about how our relations will be fetched. So we are just saying that there is a relationship, and when we want to use our objects, we just call them, and they are there. There might be preloaded, there might be loaded, lazy loaded. But here in sqlc, we don't have that, as this is pretty basic SQL, but we can, let's say, control that. We can create structures with inner structures, and then specify with sqlc embed those inner structure mappings. So we can use those functions specific to sqlc to have that. So that's great, because from the one side, we have full control over our structures, and it's still quite performant because it's just raw SQL. So that's about it about tools, and I've talked only about like maybe 10 or 20% of available DBs. So let's talk about their performance, as I already done so a bit when complaining about government pricing, how sqlc is using database SQL. But I've done some more research on the benchmarks that are done. This is the one that is from JetBrains, and the one from JetBrains. What is important here to notice is that let's say y-axis here is the time it's nanosecond per operations. So there was some quite heavy query done, and they were done on different number of records. And the better performing query will have like the lower time per operation. So as expected, database SQL and basically SQLC are at the same time on the top. You need to remember that the lower values with like 10 and 1 records are suffering from some measurement uncertainties, let's say. But the things we can see here are quite, let's say, obvious. We could expect that GORM will be the slowest one. sqlx will be slower than database SQL. It's because of that mapping that I said before, that it's done on runtime and not strictly typed. And here's another one from DBQ creator. This is the lib that I, let's say, didn't have a time to talk about. So the DBQ is quite similar to sqlx. That's why I didn't cover that, but it is a bit more performant and, let's say, less popular. It is not as popular as sqlx. So it can be also seen in a benchmark that in this case, it's really like a small upgrade from sqlx. Yeah. So after we have all this information, let's select the right tool for the job and not use sword to cut through lasagna. Starting through, before we do that, we need to think about the maintenance. So the first thing that I gathered is the date since last update, last release for each of those packages. So the tendency will be similar to star count. So GORM and sqlc are, let's say, the latest. sqlx is kind of in the middle, together with Jet, that I also didn't mention because let's say the size of this presentation. And then .sql is the least updated. It's a bit abandoned, I would say, at this point. And it can, as I said before, it is pretty similar to the packages, the number of start-of packages. So the GORM has the highest one. I was surprised that it's like twice the popular than sqlx, but that's probably because of its simplicity. It's because the one of the first ORMs, as I remember, for Go. And after that, we have and sqlc on a bit similar note. And after that, Jet and .sql are like the least popular ones here. So when I would choose each of those tools, so sqlx I would use for writing raw queries. It's like great for that, and it has some user experience improvements. For GORM, I would use it in, for example, on a hackathon when I need to have my implementation pretty fast. But I don't bother not knowing how exactly my SQL is run. In general, day-to-day use, I would use sqlc as it covers the performance problem. It has support for migration. It's like kind of all-in-one tool. Then we have GraphQL, kind of graph-like use cases. If you like graphs and you like to learn like new naming for things, I would say Ant is your friend. If you like to separate SQL from Go code without, let's say, generation of code from sqlc, .sql will be kind of good for that. And if you are a performance freak or you are creating a new package, just use database SQL. There's no better thing than that. So as we have covered the use case, the tools, the only thing that lasts for us is the testing. So for that, I have prepared just one tool to wrap it up. So it's GoSQL mock. So this is a simple library that will let us test our code. So first, let's think when we would like to test our code using, let's say, connection mocks. So we could like test our code on 3-step, on end-to-end, on integration and unit tests. So in case of end-to-end tests, we would likely have just another database that is not a production one and have all the things done that on just regular database. In case of integration, we would probably mock our data access layer to have it done to not test the whole connections. And on the unit test layer, it would be good to have tools such as SQL mock. So here's the code. We will be testing the update and insert. And to test it, we are doing this kind of test. So in that, on our mock, we are like saying we will expect for some things to happen. What is great here is that we can use regex, so we don't need to write the whole queries that we just write before. We can just say that we will update some table or we'll do some insert, and if that happens, we will return either error if we want to test for failing, or return just a result if we want to test for particular result. So that's a quite kind of, let's say, a simple example. And as I don't think there's a point to make it longer with SQL mock, it's a simple library that makes our testing easier. So final notes before we finish. So this is the list of all ORMs, maybe not all, but the most popular ORMs and query builders for SQL. You can find it under here. So you can see that the list is long, and I covered maybe 10% of that. So going through that is kind of an iceberg. So I only covered like the top of the iceberg, and this particular iceberg is the SQL iceberg. So on the bottom of it, there's a thing called all balls. Does anyone from here know what all balls is? Raise your hand, please, if you know. Yeah, so I was interested because it sounds weird, and it looks like it's just time 000 by PostgreSQL. So by their documentation is just if you want to have time 0, just write all balls. And another thing about PostgreSQL is that it is related to Vatican. So they have a fragment in their documentation about centuries, that they have -1 century, 1 century, and so on, but they don't have 0 century. And if you have a problem with that, please write to Pope and the others of Vatican. So yeah, Postgres is pretty specific in that case. And oh yeah, so I forgot to put the slide forward. That was the part of testing. Sorry for that. So on that, I think we can end this. Thank you all for attendance, and we can move to questions from your side.